Pretty much all that what we've been doing so far has been focused on finding zeros or roots. Zeros, roots mean the same thing, of quadratic equations. Today we're going to go kind of backwards. We're going to start with our zeros and work on writing equations for those zeros. So if you want to write an equation for the family of quadratics that have zeros, 2 and 5, well, that means that we know that the function is equal to 0 at x equals 2 and x equals 5. And those two zeros correspond to the factors x minus 2 and x minus 5 equals 0. So if we have zeros 2 and 5, we can write that our function is equal to x minus 2 times x minus 5. And the reason this question says the family of quadratics that have zeros 2 and 5 is that we can multiply anything. We multiply this equation by 2, by 5, by 10, by a billion, by 0.0000212. And we'll still have the same zeros of 2 and 5 because we'll still have the factors x minus 2 and x minus 5. So this is a quadratic that has zeros zeros x equals 2 and 5. The family, it's the same thing. You just write, say it's something times those things, and typically we use a in this context. Generally, when you're doing one of these problems, I am going to want you to expand, multiply this out to put your answer into standard form or as close to standard form as you can. So in this case, our family of quadratic functions is something times x squared minus 2x minus 7x, minus 2x minus 5x, which adds up to minus 7x, and then negative 2 times negative 5 gets you 10. So this right here is an equation for the family of quadratics that have zeros at 2 and 5. We can find a specific quadratic equation then if we're given an additional point. Say that the quadratic passes through the point 1, 4. We can use that point to find what a is and find the specific quadratic that is an answer to this problem. 1 is the value of x, 4 is the value of f of x, or y. So we have 4 equals a times 1 squared is 1, 7 times 1 is 7, plus 10. So then 4 equals a times negative 6 plus 10 is 4. How about that? So in this case, a equals 1. And if a equals 1, then our specific quadratic that passes through the point 1, 4 is just 1 times x squared minus 7x plus 10, which is just x squared minus 7x plus 10. So we want to write the equation of a quadratic with zeros negative 2/3 and 5 halves that passes through the point 2, 6. There are two different ways you can go about doing this. And it depends on whether you like fractions or whether you'd rather not deal with fractions. Personally, I would rather not deal with fractions, so I like to do it this way. So my two zeros are negative 2/3 and 5/2. Now, to find the factors, you could just add 2/3 over here, subtract 5/2 there, and have x plus 2/3 and x minus 5/2 as your factors, but then you'd have fractions to deal with. So what I prefer to do is to get rid of my fractions by multiplying by the denominator, and then add 2 to both sides. So I get this 0 comes from 3x plus 2 equals 0. And this one here, if we multiply by 2, you get 2x equals 5, subtract the 5, 2x minus 5 equals 0. So we get that this function is equal to something times 3x plus 2 times 2x minus 5. These are the two factors that go with those zeros. And this will look a little bit different if you leave it as a fraction and just have x plus 2/3 here, x minus 5/2 here. You'll get the same answer at the end, but you will have the fractions to deal with when you FOIL and stuff like that. So I recommend doing it this way. You can, and then we have this point, 2, 6. 2 is x, 6 is y. You can actually plug those in before you FOIL this out. I think that's sometimes a little bit easier. So it's up to you. You can expand this part and then plug in x and y, or you can plug in x and y first, solve for a, and then expand later. It doesn't really matter. So I plug in 6 for y, a times 3 times 2 is 6, plus 2 is 8. 2 times 2 is 4, minus 5 is negative 1. So then we have 6 equals negative 8a. Divide both sides by negative 8. So a is negative 6 over 8, which reduces to negative 3 over 4. So then if I want to write that equation in standard form, we know a is negative 3 over 4. And then we're multiplying that by 3x plus 2 times 2x minus 5. We can FOIL that out. 3x times 2x gets us 6x squared. Then we got minus 15x plus 4x. Negative 15 plus 4 is negative 11. And then 2 times negative 5 is negative 10. And then our last step is just to distribute the negative 3 over 4 to each term. Negative 3 over 4 times 6 over 1. Remember, all of our, when you multiply fractions, you multiply straight across. So you have negative 18 over 4, which reduces to negative, you can divide both of those by 2, so that's minus 9 over 2 x squared, plus, distributing the negative, 11 times 3 over 4 is just 33 over 4x, plus, and then 10 times negative 3 over 4, that would be 30 over 4, which would reduce, you can divide both of those by 2 to get 15 over 2. So this then is the equation for the quadratic that, with those zeros, that passes through that given point. So if we want to find the equation of the quadratic with zeros 3 plus or minus root 5 over 2 that passes through the point 2 comma 8, it's the same process we've been doing. It's just a little bit uglier because we've got this irrational thing going on, our zeros. 3 plus or minus root 5 over 2. And we want to figure out what quadratic equation goes with that. And again, we can undo our operations to figure out what that is. Multiply both sides by 2. Gets us 2x equals 3 plus or minus root 5. Subtract 3 from both sides. 2x minus 3, those aren't like terms, so we have to just leave it as 2x minus 3 equals plus or minus root 5. And now the reason we're doing it this way is because this leaves us with our radical by itself. And now we can get rid of the root by squaring both sides of the equation. We can square 2x minus 3, and we can square plus or minus root 5. Now remember, when we square 2x minus 3, that means we're taking 2x minus 3 times 2x minus 3, and we need to FOIL. It's not just 4x squared minus 9 or plus 9. We need to FOIL this out. So we take first 2x times 2x gets us 4x squared, minus 6x minus 6x gets us minus 12x, and negative 3 times negative 3 gets us 9. So that's what we get on the left side. On the right side, we have root 5. Well, when we square root 5, we just get 5. Even though it's plus or minus, it's just 5, because if you square a positive root 5, you get 5. If you square a negative, you also get positive 5. So then this 0, we can take one more step, subtract 5 from both sides. So that 0 comes from an equation. It's 4x squared minus 12x plus 4. If this is equal to 0, we wind up getting this for x. As you look at this process, you can see what we've kind of done here is completed the square, but backward. We're completing the square in reverse on this problem to get this equation back. So this is our quadratic function that has that 0. Now once again, just like all of our others, to get that 0, it could be this times any old value we want, any number we want. So this is where we use that point that we're given, plug in 2 comma 8, so that's 8 equals 4 times 2 squared minus 12 times 2 plus 4, all times a. 2 squared is 4, times 4 is 16, 12 times 2 is 24, plus 4. So we have 16 minus 24, which is negative 8, plus 4 is negative 4. So we have 8 equals negative 4a. Divide both sides by negative 4, we get that a equals negative 2. Now that we have that a, we can plug it back in. So we're f of x is equal to negative 2 times all that stuff. We distribute the negative 2 times 4x squared is negative 8x squared. Negative 2 times negative 12 gets us plus 24x. And negative 2 times 4 is a minus 8. So we've gone through 3 different cases, one where we have integer zeros, one where we have rational or fractional zeros, and one where we have irrational zeros with these nasty radicals. But hopefully this video has helped you to figure out how to write those quadratics by getting to the root of the problem.